This is lesson 13.3, evaluate trigonometric functions of any angle. Our big question here is what's a reference angle and how do we use it? So let's look at your notes here. So some general definitions of trig functions. If we let theta be an angle in standard position and let x comma y be the point where the terminal side of theta intersects the circle, x squared plus y squared equals r squared. So we've got a picture drawn in here. Our ordered pair is x, y right here. We're going to draw a right triangle with the x-axis and label the sides. So this would be my right triangle right here. I'd go over x, and I would come up y, and then my radius is right here. So that side's r. So sine of theta, now if we think about it, our right angle is in this corner right here. So our theta is this angle right here. Here's theta. So sine is opposite over hypotenuse. So opposite theta would be y, our hypotenuse would be r. So sine of theta is y over r. And again, I just found that by doing opposite over hypotenuse. Cosecant then would be the reciprocal, r over y. And y cannot be 0. For cosine theta, cosine is adjacent over hypotenuse. So my adjacent side is x over my hypotenuse again is r. So then the secant would be the reciprocal, that's r over x, and again x cannot be equal to 0. My tangent here, tangent is opposite over adjacent, so the side opposite theta is y over my adjacent side is x, so y over x, and the cotangent will then be x over y. So notice I did all of those using my SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. These are called the circular functions. So let's do this example using one of these. It says let negative 12, 5 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trigonometric functions of theta. So looking at our picture here, I'm going to draw my right triangle right in here. So if I start at 0, 0, I'm going to go left 12, so that's negative 12, and up 5, so that's positive 5. And the angle that I'm going to use is right here. This is going to be my theta. Now, 12 is going to be the adjacent angle. So I'm going to put those labels in here. 12 is my adjacent angle. 5, that's opposite theta, so that's my opposite. And then my hypotenuse is going to be right up here. So first, we need to find what our hypotenuse is. In order to find the sine, cosine, tangent, and so forth, we've got to know all 3 sides. So we've got to find our hypotenuse. So in order to do that, since this is a right triangle, we're going to let leg squared plus leg squared equal our hypotenuse squared. So we're going to use 5 squared plus a negative 12 squared has to equal our hypotenuse, which is r squared. That's our radius. So this is 169 equals our radius squared. So if we do the square root of both of them, our radius equals 13. So our hypotenuse here is 13. So now sine is opposite over hypotenuse, so that's 5 over 13. And cosecant goes along with that, so cosecant is going to be 13 over 5. Cosine adjacent over hypotenuse, that's negative 12 over 13. So our secant would be the reciprocal, so that's going to be negative 13 over 12. Tangent, opposite over adjacent, so that's 5 over, we've got a negative, I'm going to put it on the front, over negative 12. And then our cotangent would then be the reciprocal, so that's negative 12 over 5. So notice once I knew all 3 sides, I could easily find all 6 trigonometric functions. Okay, the next here is the unit circle is a circle centered at 0, 0 with a radius of 1. And you've already seen these. We've already talked about the unit circle. The circle can be used to find trigonometric functions for quadrantal angles. So what's that mean? Well, a quadrantal angle is an angle in standard position whose terminal side lies on an axis. Okay, so its terminal side lies on an axis. So what we need to remember is that the measure of a quadrantal angle is always a multiple of 90 degrees, or in radians, pi over 2. So what this is saying, it's in standard position. So one side is always right here, and then the other side always either ends here, or here, or here. So it's in standard position. That would be a quadrantal angle. So on our unit circle, let's see what the sine or cosine must be for quadrantal angle. So what I want you to remember here is the x value is our cosine of our angle, and then the y value is our sine of an angle. So at this top point right here, we get a different color to put my ordered pairs in there. That top point would be the ordered pair 0, 1. So that top point is 90 degrees. So the cosine of 90 degrees is 0. The sine of 90 degrees is 1. Similarly, the cosine of pi over 2 is 0. The sine of pi over 2 is 1. Our next quadrantal angle would end right here, and that's the ordered pair, -1, 0, and that would be a 180 degree angle. So our cosine of 180 degrees is our x value, that's -1. Our sine of 180 degrees, well, that's our y value, that would be 0. Our next quadrantal angle could end right here, and that's the ordered pair 0, -1. And going around to that spot, that would be 270 degrees. So our cosine of 270 degrees is the x value, which is 0. Our sine of 270 degrees, that's our y value, so it's -1. And then if our angle went all the way back around to here, so it's 360 degrees, well, that's the ordered pair 1, 0. So our cosine of 360 degrees is the x value, that's 1. Our sine of 360 degrees, that's our y value, and it's 0. So every ordered pair has the value cosine theta, sine theta. Okay, let's look at the next page of your 13.3 notes. It says use the unit circle to evaluate the 6 trigonometric functions for theta equals 3 pi over 2. So 3 pi over 2, well, starting here, going to here, well, that's 90 degrees, or pi over 2. Here's a 1 pi over 2, and down here would be 3 pi over 2. So this angle, that would be 3 pi over 2 radians. And that ordered pair has the ordered pair 0, -1. So the sine of 3 pi over 2 is our y value, and it's -1. The cosine of 3 pi over 2 is our x value, and that's 0. The tangent, so this is something you should remember, your tangent of a value is really the sine of that divided by the cosine of that value. So we can still use this ordered pair to find the tangent. So if I do the sine, that's -1, over the cosine is 0, and since you can never have 0 on the bottom of a fraction, it's undefined. Your cosecant, well, that's the reciprocal of sine, so if sine is -1, if we put that over 1, well, get the reciprocal, and it's still negative 1. Your secant is going to be the reciprocal of cosine, so if I put my cosine, that's 0 over 1, and flip it, I would have 1 over 0, and 0 cannot be on the bottom, so it's undefined again. For cotangent, your cotangent is going to be the reciprocal of your tangent, so it's 0 over negative 1, which is 0. Okay, let's look at our reference angle relationships. So if we let theta be an angle in standard position, the reference angle for theta, so this goes back to our big question here, is the acute angle theta formed by the terminal side of theta and the x-axis. So this right here is really theta prime. Notice the little sign right there to back that. Okay, so that stands for our reference angle. So looking here in quadrant 2, if this is my angle theta, then our reference angle is this angle right here. So to find the reference angle for quadrant 1, in degrees, you would do 180 degrees minus your theta. Or in radians, you would do pi minus your theta. For quadrant 2, so quadrant 2 would be an angle that comes all the way over here. And again, we want it in relation to the x-axis, so this right here would be our reference angle. So to find the reference angle in quadrant 2, we're going to do our theta minus 180 degrees. Or if I have it in radians, we're going to do theta minus pi. For quadrant 4, our angle would start here and come all the way around. So the closest x-axis would be right here. So that would be our reference angle. So to find the reference angle in the 4th quadrant, you're going to do 360 degrees and subtract theta. Or in radians, you're going to do 2 pi and subtract theta. So let's do an example up here. So find the reference angle theta. So we want the reference angle to negative 165. So if I picture where negative 165 would be, I'm just going to draw a quick sketch here. If I go down here, that'd be negative 90. All the way up would be negative 180. So negative 165 would be somewhere right here. That's in the 3rd quadrant. So I know this is going to be my reference angle. So I'm going to do my angle, which is negative I'm going to take my angle and do 180 minus my 165 degrees. So if I subtract those, I get 15 degrees. And the reason why this is different than our table right up here is because we have that negative 165. And that's what makes it a little bit different here. So for B, if I want to find the reference angle to 7 pi over 12, well, 7 pi over 12, that's not 1 whole pi, but it's more than a half a pi, so it'd be somewhere over here. Okay? And it's positive, so we can use our table right up above here. Our reference angle is going to be right down here. So we're just going to do 180 and not 180 because I'm in radians. So we're going to do pi minus 7 pi over 12. And if really that's 1 pi. So 1 minus 7 twelfths would be 5 twelfths. So we have 5 pi over 12. For C here, 322 degrees, well 322 degrees would be all the way around here. So that'd be my angle. My reference angle is going to be right here. So we're going to do 360 minus 322 degrees. So our reference angle is 38 degrees. So here's where we use reference angles. You can use reference angles to evaluate trig functions exactly with or without your calculator. Okay, so this is where we might use our unit circle a little bit. So it says write an equivalent statement using the same trig function and a reference angle. So if we want the sine of negative 225 degrees, so negative 225 degrees will start here and come around this way, negative 225. So negative 225 would become right about right here because halfway around would be 180. So 225 would go up a little bit further. So because it's negative, I don't follow my exact rules up there. I'm going to do 225 minus 180, and that gives me 45 degrees. So really, this is the sine of 45 degrees. And if you look at your unit circle, the one that we've constructed, the sine of 45 degrees is the square root of 2 over 2. Now we want we're not going to do cotangent, we're going to do the cosine of 5 pi over 3. So the cosine of 5 pi over 3, let's kind of draw a quick picture of where that would be. So 5 pi over 3, well that's more than 1 pi, okay, and it's more than half of another pi. So more than 1 pi, more than half of another pi would be someplace over here. So to find my reference angle, I want this as my reference angle. So I'm going to do 2 pi minus my 5 pi over 3. And if you subtract 2 minus your 5/3, you get 1/3, or pi over 3. So this is the same as our cosine of pi over 3. And if you look on your unit circle, the x value at pi over 3 is 1/2. So this value is 1/2. Okay, here's just a couple extra rules. So if we want to find the sine of an angle, that's the same as the cosine of 90 degrees minus that angle. So if I did the sine of 63, well, if I do 90 minus 63, that's 27. So this is the same as the cosine of 27 degrees. The cosine of the angle is the same as 360 degrees minus the angle, so the sine of 360 degrees minus an angle. So the cosine of 127, well, if I do 360 minus 127, that's 233. So cosine of 127 is the same as the sine of 233 degrees. And lastly, the sine of an angle is the same as the sine of 180 minus that angle. So the sine of 150, well, 180 minus 150 is 30. So the sine of 150 is the same as the sine of 30. Right here's just some extra information for you. A couple of things to think of. So if you have a reference angle theta and we want to evaluate it, you can use these to help you think of the sines. So the sine and the cosecant are going to be positive in quadrant 1, cosine and secant are going to be positive in quadrant 1, and tangent and cotangent are both going to be positive. And the way I think of it, if I start at 0, I go the positive x, the positive y to get up here. So my x is positive and my y is positive. So all of those have to be positive. In quadrant 2, if I start at 0, 0, I have to go negative x and positive y to get into quadrant 2. So negative, positive. So your cosine, the x values, and your secant are both going to be negative. Sine, cosecant are both going to be positive. And then tangent and cotangent, since they're the sine over the cosine or vice versa, well, it's positive over negative, so they're both going to be negative. In quadrant 3, they're both going to be negative because you go negative x and negative y. So sine, cosecant, cosine, secant are all negative. And then your tangent and cotangent, they're going to be negative over negative, so that'll make us a positive. And then in quadrant 4, you go in the positive x direction and negative y direction. So your cosine and your secant are both positive, your sine, cosecant are both negative, but then the tangent and cotangent are both going to be negative because you'll have a positive over negative. Okay, we've got one last problem here. It says a ship sails 512 miles at a bearing of 12 degrees. So a bearing of 12 degrees means if I start at a point, instead of going straight up, I come at an angle of 12 degrees. And it says, how far from its original position is the ship? Give your answer. And it's going 512 miles. So to find how far east it is, we're looking at this value right up here. So let's set up a problem. Here's our angle. This is the hypotenuse then. And across from it, that would be our opposite. So opposite and hypotenuse, that's sine. So sine of 12 degrees equals our opposite over hypotenuse. So let's cross multiply. I have 512 times the sine of 12 degrees equals the angle that we want. And if you put that into your calculator, you'll find that it's about 106 miles. So if you have any questions, make sure you put a star next to them, and we'll talk about them in class tomorrow. Have a good day.